Okay, something to notice right away about fractions. Let's say I had this equation. 1 over 2 is equal to x over 2. Does anybody know what x is? What is it equal to? Anyone know? 1. X equals 1. How did you know that?
Because if 1 over 2 is equal to x over 2, then x has to be 1.
Yeah. There's the only one possibility. So a strategy when it comes to solving equations, if the denominators are equal, right? Denominators are equal, then what would be true about the numerators? Yeah. Then the numerators are equal. Okay, so when solving linear equations and inequalities that contain fractions, one technique is to find the least common multiple of the denominators. By the way, that's the same thing as the least common denominator. Least common denominator is the same thing as least common multiple of the denominators. Oh, that's what it says, known as the least common denominator, the LCD. And to multiply each side by that number, the result is that the fractions disappear and the equation is much easier to solve if we perform the arithmetic with fractions than if we do. Okay, so for the first one, they actually are ready. And by the way, 1/3 y. What's another way of writing 1/3 y? You're right. But I want it so that okay, let's just do it off to the side. 1/3 y is the same thing as 1/3 times y over what? 1, which is y over 3. And the reason why I'm doing that is because I want all the denominators to be the same, and so I want to just multiply this out, just so that we know y over 3 plus 2 over 3 equals 7 over 3. So if we want to get rid of that 3, the idea is, well, they all have the same denominator, just like we showed in the last example, the easier example. If all the denominators are equal to each other, that means the numerators are equal to each other. So right away, if I see this, I can cross these out. The math that is involved in this is I'm basically multiplying everything by 3. Because I can do whatever I want so long as I do the same thing on both sides, correct? Yes? Okay, so then these 3's cancel, don't they? 3 divided by 3. So we get y plus 2 equals 7. Is that a much easier problem to solve than the original one? Well, it looks a lot less intimidating, doesn't it? To not have those fractions there. So what's that? Well, I have a 1 implied always right there, right? Yeah, because just like you, Abdi, there's only one of you, but you don't walk around with a 1 in front of you, right? So y, even though if y is standing by itself, it's implied that there's only one of them. We could put the 1 there because 3 divided by 3 is 1, right? But we don't really have to because it means the same thing. Okay, now how do we get y by itself? Subtract 2, y equals 5. Okay, and we always have to make sure that we check. So for an additional point, let's check. So now we have 1/3. Now we're always going to check in the original. Check in original. Because if we made a mistake, we don't want to just check it back here. What if I made a mistake going from here to here? So we have 5 plus 2 over 3 equals 7 over 3. We don't know if this is true yet, so we put in a question mark. How do we multiply 3 times 5, or 1/3, sorry, times 5? 5 over 1. So here we get 5/3 plus 2/3. Is it equal to 7/3? Is that true? Yep, it worked out. 7/3 is equal to 7/3. Am I done? Is there anything else I should do? One more step. State my solution. The solution is 5. Or you can also write it in set notation, 5. Okay. So for this one, we don't have all common denominators. I will tell you that the easiest way to do this is to make all of your fractions have common denominators. That's what students have told me is the easier way. Because you could multiply both sides by the lowest common denominator. Does anybody know right now out of 3, 2, and 6, what's the lowest common denominator? 6. So the lowest common denominator is 6. So actually, let me show you the first way where we would get them all to have the same denominator. And then I can show you sort of a shortcut way. So the first way is to say, okay, 1/2, I'm just going to rewrite the problem since it's all cluttered up in here, plus 1/3 equals 1/6t. Here's another reason why we check it, because sometimes we rewrite the problem when we write it wrong. Did I write it right? What do I have to do to 1/2 to make it have a denominator of 6? By 3/3. I'm multiplying it by 1, so I'm not changing the value, right? If I multiply this one, if I want this, so this is actually now 3/6t. And actually that t can go up top with the 3, just like we proved before because it's over 1. Okay, what are we going to multiply 1/3 by? 2/2, right? So we get 2/6 equals, we don't have to change this one because it already has a 6, but let's move the t to the top. That'll make it a little easier when we clear the fractions. Because remember, it's just t over 1. So 1 times t is 1t. 1 times 6 is 6. And then minus, what are we going to multiply this one by? 2/2. 2/2 is going to give us 2/6. So now if they all have the same denominator, that means everything is being divided by 6. What does a denominator of 6 mean? It really just means divide by 6. So if I want to undo that, I multiply by 6, right? Over 1. I'm basically just getting rid of the 6 in the denominator. Multiply everything by 6 over 1. Those cancel, those cancel, those cancel, those cancel. And we get 3t plus 2 equals 1t minus 2. Essentially because all the denominators were the same. You know, I had a friend, she was taking math. When she would get to this stage, she would just cross out the 6's and then there's her equation. This is getting really messy. You know, but I'm trying to make you understand why the 6's just disappear. And it's because if every denominator is equal, then we know the numerators have to be equal, right? So here's our equation. That's a lot easier to solve. What would you do to solve this one? Minus t, right? How many t's do you get? 2t minus 2 equals, these are gone. How many numbers do you have? -2 minus 2 is -4, right? Divide by 2. T is equal to -2. Okay, I want to show you the other way to do it. Because this is going to work for many people to just make them all have the same denominator. And remember, every single term has to have that denominator. But here's how it looks if you do it sort of like a little shortcut way. Plus 1/3 equals 1/6t minus 1/3. So what they're saying in the instructions above is they said, multiply both sides by the lowest common denominator. And we said the lowest common denominator again was 6. So this is actually the exact same thing, okay? But instead of making them all have 6, I'm going to say, okay, I'm going to multiply this term by 6. I'm going to multiply this term by 6, this term by 6, this term by 6. 6 over 1, right? How many times does 2 go into 6? 3 times. So 2 goes into 6 3 times. 3 times 1 times t is 3t. You see that? How many times does 3 go into 6? 1 times 2 is 2. How many times does 6 go into 6? 1. Equals, there's our equal sign. 1 times t, this is 1, is t, right? And then how many times does 3 go into 6? 2 times. 1, negative, 1, 2. 1 times 2, negative 2. Do you see that I got the exact same thing? For some of you, multiplying both sides by the lowest common denominator is okay. And then for some of you, it's like, that's too much happening all at once. So feel free to take it, really when you do it, when you make sure they all have the same denominator, you're really doing the exact same thing. It's just maybe for some people it's easier to see that equivalent fraction happening. Okay? And then remember that you always need to check. And we want to make sure we do our check in the original problem. So our answer was -2. And my pen is running out, so I'll use a different pen here. So we're going to go back to the original. We have 1/2 times -2 plus 1/3. Is it equal to 1/6 times -2 minus 1/3? Okay, let's hope I did it right. Dun, dun, dun. Okay, so here we have -1, don't we? Plus 1/3. -1 is the same thing as 3/3. If I want a common denominator. So what do I get now? -2/3. Okay. Here, if I want, I can cross cancel. So, because that would be a reduced fraction, 1/3, and it's negative. -1/3 minus 1/3. What's that equal to? -2/3. And if it felt like it was too much to do by hand, you could also plug it in your calculator as well. So you might try that out when I'm coming around. You're just basically wanting to see that whatever you plug in is going to give you the same thing on both sides. Any questions about that so far? Did I go too fast? Yes? Should we do one more together? Okay. Slowly. Which method, Abdi, do you like better? This one or this one? Second one or first one? Oh, you were saying the checking happened too fast? All of it. Okay. Let's try one more problem, okay? We're going to go on the back page, and then you guys will end up doing the group work problem together in groups. Okay, this one is a little bit harder, and now what I will suggest is when you see this variable out to the side, you might write it as 1 times m over 3, minus 2/5 equals 3m over 4 minus 7/6. Okay, what's the lowest common denominator? 60. Lowest common denominator. Lowest common denominator is what we would need if we were going to add fractions. So we need to find a number that all of these numbers go into. So if you think about multiples of 3, multiples of 5, well, if you were going to add these fractions, what would be the common denominator between 3 and 5? 15, because in order for them to add, they have to have the same denominator, a number that 3 and 5 both go into. Okay, what would be the smallest number that 4 and 6 would go into? 24. So actually, a way that you can find 12. You're right, 12. Yes, that would be lower than 24. You're right. So another way to find the lowest common denominator is you can find the prime factorization. Prime factorization. Well, 3 is prime. So it's prime factorization. It's just 3. 5 is prime as well. So 5 times 3. Okay. Then for 4 and 6, the reason why you got 12 was because 2 times 2 is 4, but 2 times 3 is 6. So you see, this is the 4, here's the 6. They have a common factor of 2. So 6 has a 2 and 4 has a 2. That's their common factor. I only have to use the common factor once. And now we have, oh, and actually look, 3 is also, you don't need to use the 3 twice. So 3 times 4 times 5, here's the 4. Since 3 is already included in 3, you don't have to double it up. 3 is included in 6 as well. So 20 times 3 is 60. Is that what you got? No, wait. Yeah, 20 times 3 is 60. Is that the lowest common denominator you guys got? 60. So we want every single one of these to have a denominator of 60. So what times 3 gives us 60? 20. So we're going to multiply by 20 over 20, 20m over 60. What do we have to multiply by 5 in order to get, 60. I want 60 in the denominator. Scratch that too. We have to multiply by 12. Because you can see here, 3 and 4 multiply to 12. The 5 is the thing that would multiply to 60. So 12 and 12, we get 24 over 60. We're just making equivalent fractions here. Equals, what do we have to multiply by 4 to get 60? Yeah, and here's the 15, and here's the 4. So 15 over 15 gives us 45m over 60 minus, what do we have to multiply by 6? 10 minus 70 over 60. Now, what's the equation that you're going to solve? Now that they all have a denominator of 60, what equation do we have left if we get rid of the denominator? If the denominator is all the same, that means the numerator is equal. 20m minus 24 equals 45m minus 70. So that's just the clearing fractions portion. Go ahead and solve and check the rest, and I'll come around to see if we have questions.